Hello everyone, I'm Prashant Gandhi. Welcome to my channel. Today we'll discuss about binomial theorem and we'll discuss some of the problems of this binomial theorem. So first of all, in binomial theorem, what is binomial theorem? So first of all, we know a plus b whole square. Suppose this type of term a plus b whole square. We are familiar with this type of expression a plus b whole square. We know what is the value of a plus b whole square. It will be a square plus 2ab plus b square. Okay, now next, suppose it is a plus b whole cube. We are also familiar with this one, that will be a cube plus 3a square b plus 3ab square plus b cube, like this. So this is a plus b whole cube. Now we can see there is a pattern. What is the pattern? Look at here. This is the first term a and the power is here 2. So here the first term is coming a square. Now the power of a is decreasing. That means here the power of a become 1 and the power of b is increasing. That means the power of b here 1. Now next step, power of a again in decreasing. Power of a decreasing means there will be no a, and the last term power of b increasing. So power become 2. Look at this one. Again, here the first term is a, the power is 3, so it is a cube. Now look at the next term, the power of a is decreasing, that means it becomes 2, and the power of b increasing, that means here it is no b, in the next term it is a b to the power 1. Again in the next step, look, the power of a decreasing, that means the power become 1, because in the last step the power was 2, but here you can see the power is become 1. And look at the power here 1, and the next step power of b become 2, that means power of b is increasing. And in the last step again power of a decrease, that means there is no power of a, and the power of b increasing, that means it is 3, so b to the power 3. So a plus b whole cube becomes like this. So here what will be a to the power a plus b, suppose whole to the power 5. How to write a plus b whole to the power 5? Same thing. Look, what is the highest power here? 5. So it will be a to the power 5 plus. Now next term, what will be the next term? Now we know from this pattern we see that the power of a is decreasing and power of b is increasing. So what will be the next power of a? The power of a will be decreasing, that means it becomes 4 into b to the power 1, because power of b is increasing. Now plus next term, power of a again decreasing, that means it becomes 3, and power of b increasing, that means it becomes 2, like this. Now what will be the next one? Guess that one. What will be the next one will be again a 2, that means power of a in decreasing and power of b increasing, that becomes 3 plus. Now again a and b to the power 4 plus next one is b to the power 5, like this. Done. Now we can see from here what is the first. Now here look at the coefficients here, 3. Here you can see there is a 2. Now what will be the coefficient? The coefficient will be here, look at the highest power 5, so the first coefficient will be here 5c1. First here it will be 5c0, it will start from 5c0, but something c0 will be 1, that's why you don't need to write this one. So next one is 5c1, then next one will be 5c2, next it will be 5c3, next it will be 5c4, next it will be 5c5, like this. So this is the form a plus b whole to the power 5. It is a to the power 5 and 5c0 is 1 plus 5c1 a to the power 4 b, 5c2 a cube b square, 5c3 a square b cube plus 5c4 a b to the power 4 plus 5c5 b to the power 5. Now what is 5c0, 5c1, 5c2? We have to find the value of this one. So how to find? We know the value of NCR. What is the formula? NCR, n factorial by n minus r factorial into r factorial. So first of all 5c0, something c0, that will be 1. Next one is 5c1, that is 5 only. 5c1 is 5, 4c1 is 4, 3c1 is 3, like this. Now 5c2, how to find this one? 5c2, you can use the formula. So what is the formula? 5 factorial by 5 minus 2 factorial, that means 3 factorial into 2 factorial like this. Now 5 factorial can be written as 5, 4, 3 factorial by, this will be 3 factorial into 2 factorial can be written as 2 into 1. So 3 factorial cancel out, and by 2 it will be 2. That means it become 10. So 5c2 is 10. Now what will be 5c3? Now there is a symmetry. What is the symmetry here? Look, 5c3. Now look at the power here. Here it is 2. Now here it is 3. Now 2 plus 3, it is coming 5. That means whatever be the value of 5c2, the value of 5c3 will be the same. That means it will be 10. What does it mean? Suppose for example 10c4 and 10c6 both will have the same values. Why? Because here you can see 4, here it is 6. 4 plus 6 is 10, and here you can see this is 10. That means 10c4 and 10c6 will have the same values because this is the symmetry. Now here also 5c2 and 5c3 will have the same value because 5c2, here 5c3 both. Here you can see 3 and here it is 2. 3 plus 2 is 5. So it is coming 5 here. So those will have the same value, and that will be 5. We know 5c2 the value is 10, so that's why 5c3 also will be the value 10. Now next one is 5c4. So what will be the value of 5c4? Again same thing. Look at here, 5c4 and 5c1 both will be same because we can see 4 and here it is 1. 4 plus 1 is 5. It is coming 5. That means 5c4 and 5c1 has the same value, and the value, we know the value of 5c1 is 5. So 5c4 will also be 5. Done. And next 5c5. What will be the value of 5c5? Because if both are same NCN, then the value will be 1 like this. So those are the values. Now if I put here the values, what will happen? It will become like this: a plus b whole to the power 5. Now what was the expansion? The expansion was 5c0 a to the power 5, and we see 5c0 is 1. That means it will be only a to the power 5 plus next 5c1. 5c1 means 5 a to the power 4 into b plus next 5c2. 5c2 means 10. That means 10 a cube b square plus next one is here 5c3. 5c3 means here we can see 10 again, so that will be a square b cube plus next 5c4, it is 5, so that will be 5ab to the power 4, and next one is 5c5, that means 1, that means b to the power 5. So a plus b whole to the power 5, that will be the expansion like this. A plus b whole to the power 5. A similar way you can expand a plus b whole to the power 6 or a plus b whole to the power 9, a plus b whole to the power 10 like this. So this is the format. This is the format you have to remember. The format is here, first power will be decreasing, and for the next one the power will be increasing, and what will be the coefficient? The coefficient will be like this: 50, nc0, nc1, nc2 like this. So what will be the general expansion here? So if I expand this one, a plus b whole to the power n, what will be the formula? So first term, what will be the first term? A to the power n plus, now next term a power of a will be decreasing, that means it will become a to the power n minus 1, and the power of b will be increasing, that means b to the power 1. Next again a to the power, it will be again decreasing, n minus 2 into b to the power 2 plus again a to the power n minus 3 into b to the power 3 plus dot dot dot. The last step, in the last step the power of a will be decreasing, that means a to the power n minus n into b to the power n like this. And what will be the coefficients? The coefficients will be, first time it will be nc0, and we know nc0 is 1, so no need to write this one. The next one will be nc1, next term will be nc2, then nc3, and so on. The last one will be ncn, so last term will be ncn like this. Okay, so this is the way to solve this type of thing. So whenever there is a plus b whole to the power n, we can use this type of thing. Okay, so this type of thing you have to remember. So first thing you have to remember, the power, first term will be decreasing, and for the second one it will be increasing. Now we can see there are two terms, so that's why it is called a binomial. So binomial, this is the way to expand. Now from this, here we can find general term. What is general term here? General term. So now look at the expansion properly. If I look this expansion a plus b whole to the power n properly, so look at the second term. If I see here, second term is here nc1 a to the power n minus 1 into b to the power 1. That means whenever I am saying second term, it is coming nc1. Okay, now look at the third term. What is the third term here? nc2. So whenever third term, it is coming nc2, one less. Now what will be the general expansion here? General form will be tr plus 1. So you can see whatever be the number of term, here the value is coming one less. That means if it is third term, it is coming nc2. If it is fourth term, it is coming one less. That means nc3, like this. So here what will be r plus 1 term? That will be nc 1 less. That means r minus 1, r plus 1 minus 1. That will be ncr into, now a to the power n minus. Now look at here. So what is the formula? Look, nc1 here, and the power is here n minus 1. nc2 here, the power is here n minus 2. So here also it will be a to the power n minus r, because ncr is here, into b to the power. Now look at the power here. N, since it was nc1, the power was 1. Since it was nc2, power was 2. Since here the nc3, power is here 3. So if it is ncr, the power will be r. So this is the general term, and this is the main thing of binomial. This is a very important thing, and all about binomial is here only, general term. So you should remember what is the general term. So this is the r plus 1 term formula. Okay, so tr plus 1 ncr a to the power n minus r into b to the power r. This formula you have to remember, because this is a very important thing for whole chapter of binomial theorem. Okay, now next one, number of terms. Now next is number of terms. How to find number of terms in binomial? Now if I see properly, look at the patterns. If you know the pattern properly, you can find easily how many terms will be there in a binomial. Suppose this is a plus b whole square. So if I expand this one, how many terms will get? I will get like this, a square plus 2ab plus b square. So how many terms are there? There are 3 terms. That means whatever be the power, we are getting one more extra term. That means if a plus b whole to the power n is there, if it is a plus b whole to the power n, then we can say number of terms of this one will be n plus 1. So this is the formula. If it is a binomial, the highest power is n here, so number of terms will be n plus 1. That means for example, suppose it is given a plus b whole to the power 20. A plus b whole to the power 20. How many terms are there in a plus b whole to the power 20? Now you can see the power is here 20. So number of terms will be 20 plus 1. That means 21. So this is the number of terms. That's for the binomial, if the power is here n, the number of terms will be n plus 1, like this. Now next, suppose it is given like this, a plus b plus c, a plus b plus c whole to the power suppose 5. Now how many terms are there in a plus b plus c whole to the power c? Now you can say this is not a binomial, because you can see there is a plus b plus c, 3 terms are there. So how to use that one? So for that one, first I am taking this one a plus b as a single term. Suppose this is my a and this one is a b. So a plus b whole to the power 5, like this. Now if I expand this one, what will happen? That will like this, a to the power 5, because this a plus b, I have taken this whole as a. So this is a plus b whole to the power 5 plus next 5c1 a plus b whole to the power 4 into c. Next it will be 5c2 a plus b whole cube into c square and so on, and like this the last term will be 5c5 c to the power 5. Now observe this one properly. If I observe properly, now look, this one a plus b whole to the power 5, this is a binomial. So how many terms we'll get from this binomial? The power is here 5, we'll get 5 plus 1, that means 6 terms from here, because this is a binomial and the power is here 5. So you know, if the power is n, how many terms we'll get? We'll get n plus 1 term, that means 6 terms from here plus. Now next one is, look at here, 4. So how many terms we'll get? 4 plus 1, that means 5, because if you multiply this one, multiply, see, there will be 5 terms only, same things will be there, so 5 terms. Now next we'll get again same thing, power is here 3, that means we'll get 4 terms like this, 3, then we'll get 2, and from the last one we're getting only 1 term. So we are getting 1 plus 2 plus 3 plus 4 plus 5 plus 6. So if I arrange like this, 1 plus 2 plus 3 plus 4 plus 5 plus 6, now we can see there is a formula, because to add n natural numbers, the formula is n into n plus 1 by 2. So here it will be 6 into 6 plus 1 by 2. Now if I solve this one, that will be 3 into 7, that will be 21. Now we can see, if the power is, if there are 3 terms here, a plus b plus c whole to the power 5, if there are 3 terms and the power is here n, so what will be the formula? So number of terms, if there is a plus b plus c whole to the power n type of thing, and number of terms, what will be number of terms? The number of terms will be, we can guess from this one. So look at here, so highest power is here 5, so we are getting here 6 into 6 plus 1. So that means whatever with the power, you are getting one more. So that means first it will be n, so it will be one more, that means n plus 1 into, what is the next term? 6 plus 1, that means n plus 1 plus 1, so that will be n plus 2 by 2. So that will be the number of terms for a plus b plus c whole to the power n. That means if suppose this type of thing is given, x plus y plus z whole to the power, suppose it is given 10. So how many terms will be there? So number of terms from here, number of terms will be like this. So first the power is 10, so we have to take 1 extra, that means it will be 11 into 11 plus 1, that means 12 by 2. So if I cancel out, that will become 66. So number of terms will be here 66, like this. Okay, so this is the way to find number of terms of a binomial. Done. Now next one, number 2. In number 2, suppose I have given one thing, we can, so we'll solve a question here. Number 1, 1 plus 2x plus x square whole to the power 7. So how many terms are there in this binomial, and this expression, how many terms we'll get if I expand this one? Now for this one, you can see there are 3 terms are there, but we know this is a formula, 1 plus 2x plus x square. So if this is a formula, you have to reduce that to a formula. So what is the formula? X plus 1 whole square, and the power is here, the power is here 7, so it can be written as x plus 1 whole to the power 14. So you can see now this is a binomial a plus b whole to the power 14 type of form. So whole to the power n. So how many terms will be there? So number of terms will be here, number of terms will be 14 plus 1, that means 15. So in this binomial, the number of terms will be 15. So this is the question number 1. Now we will move to question number 2. Next question, question number 2. This is also very important one. Suppose it is given 1.1 whole to the power 10,000, it is given 10,000 or 1000. Which one is, two numbers are given, one number is 1.1 to the power 10,000 or 1000. We have to find which one is greater. From these two numbers, we have to tell which number is greater. Now using binomial, how to solve this type of problem? So first of all, we know the formula of a plus b whole to the power n, how to expand this one. Okay, so what will be 1 plus x whole to the power n? So this is very easy. So 1 plus x whole to the power n will be 1 plus, if we use the same thing, I will get that one. So 1 plus that will be nc1 into x plus nc2 into x square plus nc3 into x cube and so on, and up to this ncn whole to the x to the power n. So this is the expansion of 1 plus x whole to the power n. So here also we have to use that one only. So you can see there 1.1 to the power 10,000. Now how to solve this? 1.1 that can be written as 1 plus 0.1 to the power 10,000. Okay, so 1 plus 0.1 to the power 10,000. Now how to solve this? We can see this is 1 plus x whole to the power n formula. This one 1 plus x whole to the power n formula. So what is the formula here? 1 plus nc1, that means 10,000 c1 into x, here the x is 0.1, plus next one will be 10,000 c2 into 0.1 whole square. Done. And like this again 10,000 c3 0.1 whole cube and so on. The last term will be 10,000 c 10,000 and ncn the value is 1 into 0.1 whole to the power 10,000, like this. Okay, now next one is 10,000 c1. Now nc1, what is the value of nc1? The value of nc1 is n. So here 10,000 c1 that can be written as 10,000. So it can be written as like this: 1 plus 10,000 into 0.1. Now 0.1, if I remove the point, that will be 1 by 10 plus next 10,000 c2 0.1 whole square plus dot 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 like this 10,000 c 10,000. Last time will be 10,000 c 10,000, that means 1 into 0.1 whole to the power 10,000, like this. Okay, now you can see this one. So you can see 10,000 and this 0 will be cancelled, that means 1,000, that is becoming 1,001 plus some positive value. So you can see these two is forming 1,001 plus those are the positive terms. So you can write now 1,000 and plus 1 plus 1, that will be greater than 1,000, because we know 1,001 is greater than 1,000 here, and plus some positive terms are there. So that means this whole quantity will be greater than 1,000. So from here we can write 1.1 whole to the power 10,000 will be greater than 1,000. So using the binomial we establish that here 1.1 to the power 10,000 is greater than the 1,000. So we can use, so only we have used the formula a plus b whole to the power n. Okay, so this is the way to solve this. Now we'll move to question number 3. So question number 3. Now in the question number 3, the question is like this. This type of question is also can be solved by mathematical induction. Okay, but we'll solve it using binomial. So what is the problem here? It is given, suppose it is given 2 to the power 3n minus 7n minus 1 is, prove that we need to prove. Okay, so prove that this one is divisible by 49, is divisible by 49. So we have to show that this expression 2 to the power 3n minus 7 minus 1 is divisible by 49. Now how to show that this one is divisible by 49? So first of all, look at here, 2 cube whole to the power n, 2 to the power 3n can be written as 2 cube whole to the power n minus 7n minus 1. Now 2 cube can be written as 8, so 8 to the power n minus 7n minus 1, like this. Now 8 can be written as 1 plus 7, so it can be written as 1 plus 7 whole to the power n minus 7n minus 1. Now this is a 1 plus x whole to the power n formula, and I have given the formula 1 plus x whole to the power n. So what is the formula? 1 plus nc1 x to the power 1. Next nc2 x to the power 2 plus nc3 x to the power 3, and so on like this. ncn x to the power n, ncn sorry ncn x to the power n, like this. So here you can see, so here one second, so that will be ncn x to the power n, that means ncn 7 to the power n, like this. And here minus 7n minus 1, so you can see 1 cancel out. Now nc1, what is the value of nc1? The nc1 is n, so that will become 7n, and here is also 7n, so 7n and this 7n will be cancelled out, so it will be remaining 8 nc2 7 square plus nc3 7 cube plus dot 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 ncn 7 to the power n. Now from this overall we can see what is the common element, 7 square. Now from here we can take 7 square. If I take 7 square, that will become nc2 plus nc3 into, if I take 7 square, that will become 7 to the power 1 plus dot dot dot, that will be ncn into 7 to the power n minus 2, like this. Now you can say this is 7 square 49, and this is integer. If I solve this one, that will become an integer, so it's 49 into some integer, we can write it as k, so 49k. So you can see this whole expression, that means this expression 2 to the power 3n minus 7n minus 1 becoming 40nk, that means this whole expression 2 to the power 3n minus 7n minus 1 is divisible by 41, because it can be written as 49k, so it is divisible by 49. Okay, so this is the proof. So this is the way you can prove using binomial. This same thing can be proved using the mathematical induction. If it is not written mathematical induction, you can use binomial also to prove that type of thing. Okay, so in the next I am giving same type of thing, you can practice this one. Okay, so this one you can practice. Next one is suppose it is given 3 to the power 3n minus 26n minus 1 is divisible by 676. N belongs to natural number. For all n belongs to natural number, this one. Okay, so it's the same way we can solve this one. Now next one, question number suppose I think question number 4. So next one will be question number 4. So question number 4 is like this. This is also a good question. The question is given like this: summation r equals to 0 to n 3 to the power r ncr 4 to the power n, like this it is given. We have to prove that one, we have to show this one. Okay, so 3 to the power r ncr equals to 4 to the power n summation. So how to prove this one? So we can see this is 4 to the power n, so we'll start from RHS. So this is 4 to the power n. Now 4 to the power n can be written as 1 plus 3 whole to the power n, like this. Now again the same thing, 1 plus x whole to the power n formula. So the formula is 1 plus nc1 x to the power 1. Next it will be nc2 x to the power 2, and so on up to this ncn x to the power n. Now the first term is here n 1, so first term can be written as like this: nc0 into 3 to the power 0, because nc0 is 1, 3 to the power 0 is also 1, plus next one is nc1 3 to the power 1 plus nc2 3 to the power 2, like this ncn 3 to the power n. Now you can see here, now how to write this one. Okay, so this is plus 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 like this. Now whenever there is a plus, we can write like this summation. So since there is a plus 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 like this, we can write a summation here. Now look at here. So first write what is the similar term here. So you can see NC here, NC and 3. This is a similar term. So I am writing this one like this, NC into 3. Now what is the change here? You can see this one, NC 0. It is changing. Next time it becoming 1. It becoming 2. And look at the power. Power is also changing. 0, then 1, then 2 and so on. So whatever be the change one, so take it as R. So change is here NCR 3 to the power R. Since it is whatever be the changing, take it as R. Now what is the lowest value of R? We can see the lowest value of R is 0. Here also lowest value of R is 0. And what is the highest value of R? N. So you can see the highest power of R is here N. So for here R equals to 0 and it is going to N. So NCR into 3 to the power R. Look at this. This comes the proof. So this is the way we can prove this type of thing. Okay, so using the binomial, we have proved that one. Summation 3 to the power R NCR equals to 4 to the power N. Now next, question number 5. Now for question number 5, we have to use general term formula. Now general term formula, we just introduced that formula. What was the formula? The formula was, if there is a term a plus b whole to the power n, if this is an expression is given a plus b whole to the power n, so what will be the r plus 1 term? The r plus 1 term will be NCR a to the power n minus r into b to the power r. That was the general term. Now question number 5. Now what is the question number 5? The question number 5 is given like this. Find the fourth term of x minus 2y whole to the power 12. Okay, so we have to find the fourth term of this one, x minus y whole to the power 12. Now how to find this fourth term? Now fourth term, it can be written as T4. So T4, so for using this formula, you have to write like this, r plus 1. So plus 1, that means T4 can be written as 3 plus 1 like this. Now what was the formula? NCR. So here you can see what is the n. The n is here 12 and the r is here 3. So 12C3 into a to the power n minus r. Now look at here, what is a here? X. So x to the power n minus r into b to the power r. B is here minus 2y. That means minus 2y whole to the power r. So we can see it is 12C3 into x to the power 9 into, now here minus 2 cube, that means minus 8y cube. So it can be written as minus 12C3 into 8 x to the power 9y cube like this. And 12C3 you can calculate using NCR formula, or you can use calculator to find the value of 12C3. So this is the way to find any term, 4th term, 5th term, 6th term, 10th term, any term. You have to write this. Okay, write like this, r plus 1. Suppose I need to find 10 term, that means you have to write T9 plus 1 and then use the formula, we'll get the answer. Okay, so this is question number 5. Now question number 6, similar like this, but there is a change. So what is the question number 6? Question number 6 like this, find suppose 5th. Okay, find 5th term from end of a plus 2b whole to the power, suppose it is given 10. Okay, so find the 5th term from the end of a plus b whole to the power 10. So how to do this one? Whenever this type of thing is given from the end, remember this one, from the end this type of thing is given, what we need to do is that first reverse this one. That means a will come here and 2b will come here. So it will become 2b plus a whole to the power 10 like this. So whenever it is written from the end, So just reverse the 2, and that means a will come to 2b and 2b will come to a, like this. Now find this one the same way. We have to find fifth term, that means we have to write t4 plus 1. Okay, same thing, 10 ncr, that means 10c4 a, here a will be 2b whole to the power n minus r into a to the power r, like this. Okay, so whenever it is from n, we have to just replace that one, reverse that one, and we'll get the answers. And then the same thing we have to do, we'll get the answer, like this. Okay, so and then we have to find the value 10c4, then like this, whatever be the value it will come, like 10c4 into 2 to the power 6. Okay, so it will come like this, 2 to the power, so where it is gone, so it is a, na? It is a, so at the end it will be it is given, yes it is a, so it will be 2 to the power 6 b to the power 6 into a to the power 4, and you have to solve this, you will get the answer. So like this, whenever it is given from the end, we have to use that formula. Okay, now we have to just reverse that one and then use the formula. So now question number we'll use, so this is the way to solve this type of problem. In the next videos we will solve several problems of binomial. So for today, that is the end. Thank you for today, and the next class we will solve several problems of binomials.